How do grid codes affect renewable energy grid-tied systems? Have you ever wondered how renewable energy sources like solar panels and wind turbines connect to our electric grid? The answer lies in something called grid codes. These are technical regulations that set the rules for any facility that connects to the public electric grid, including renewable energy grid-tied systems. Let's break down how these codes impact renewable energy systems. First off, grid codes outline the connection requirements for renewable generators. This means they specify the technical parameters that must be met for a system to connect to the grid. For instance, there are strict voltage and frequency ranges that these systems must operate within. They also set standards for power quality and limits on harmonic distortion. Meeting these requirements is essential to ensure that renewable systems do not disrupt the stability or quality of the grid. Another important aspect is dynamic response and ride-through capability. Renewable energy systems must be able to handle short disturbances like voltage dips without disconnecting from the grid. Grid codes often requiring these systems to maintain operation during faults or transient events. For example, wind turbines and solar inverters need to support voltage regulation and provide reactive power support during these events, which helps keep the grid stable. Grid codes also requiring renewable systems to participate in frequency and voltage control. This means they may need to adjust their power output based on grid conditions. By doing this, they help balance supply and demand, ensuring that system voltage remains within acceptable limits. Power factor and reactive power are other key points. Many grid codes set limits on power factor, which is the ratio of active power to apparent power. Renewable systems may need to supply or absorb reactive power as needed. This capability is vital for voltage regulation on the grid and helps reduce energy losses. Communication and control interfaces are also mandated by grid codes. These protocols allow grid operators to monitor and control renewable energy plants in real time. This is especially important for integrating variable renewable sources while maintaining grid reliability. Grid codes also promote fair access and standardization. By defining uniform technical standards, they create a level playing field for all generators, including renewables. This standardization facilitates grid access and integration of diverse renewable technologies, encouraging competition and innovation. Lastly, grid codes include operational and safety procedures. These rules ensure that renewable systems operate safely and coordinate effectively with other grid assets, both under normal and emergency conditions. In practical terms, compliance with grid codes means that renewable energy systems need advanced inverter technologies, control algorithms, and protection schemes that meet these specifications. This allows renewables to contribute not only energy but also essential services for grid stability. Overall, grid codes play a vital role in shaping the design, operation, and integration of renewable energy grid-tied systems. By setting mandatory technical standards, they ensure that these systems support the secure and stable functioning of the electric power grid.